Good afternoon and a very warm welcome to this special session ADAS Webinar 2023, brought to you in association with Dassault Systems and Capgemini. With the growing talk around vehicle and road safety, advanced driver assistance system or ADAS technologies have emerged as promising solutions to reduce road accidents as well as enhance driving convenience. ADAS features such as autonomous emergency braking or AEB, lane departure warning, and adaptive cruise control, which are stepping stones towards full autonomous driving or AD, work on the fusion of data from various sensors strategically placed in a vehicle. These sensors, such as radar, LiDAR, ultrasonic sensors, as well as cameras, enable the vehicle to prevent an accident by either sounding an alarm, flashing a visual warning, or completely taking over control from the driver in case of an emergency. While various OEMs have started offering ADAS functions in their higher spec vehicles, the technology is likely to be democratized in the coming future. However, the development of ADAS is a complex process and one that requires a mix of extensive virtual and real-world testing. Furthermore, mounting challenges such as complex regulations, stringent safety standards, and global demands see many OEMs and their suppliers lacking the necessary tools and expertise to meet the rapidly evolving needs of autonomous mobility. To solve these challenges, technology giants Dassault Systems and Capgemini have joined forces to offer a comprehensive solution that covers the entire ADAS lifecycle from its design to operation. This solution streamlines the ADAS development process, expedites market entry, and reduces the cost, particularly in the system engineering, simulation, and verification and validation activities for both system and software layers. Good afternoon once again. My name is Mayank Dhingra, and over the course of the next 60 minutes, this webinar will take you through the nuances of ADAS development and help you understand how the end-to-end tool chain based on the Dassault Systems 3D Experience platform enables rigorous ADAS testing and validation by utilizing digital twin and real-world data. We will have our experts give you a detailed overview about the comprehensive solution and would be happy to answer all your questions towards the end. With that, I would like to invite our speakers, Mr. Jurel Malpius from Dassault Systems and Mr. Osama Ben Musa representing Capgemini. A quick introduction to both of them. Mr. Malpius is the business lead for CATIA AD ADAS at Dassault Systems. He joined the company in 2017, and prior to that, he was part of the Simulia brand in Germany for over 6 years. His focus is on strategic business development for the automotive industry. Mr. Osama Ben Musa is the CTO Autonomous Mobility at Capgemini and is the founder of Capgemini's ADAS Academy, which is a training and skill development structure that addresses the needs for dedicated specialists to design ADAS and autonomous cars. Mr. Musa has applied for over 10 French and European patents related to energy storage, engine performance, and innovative driver assistance systems. Before I hand it over to our presenters, I would like to request the audience to key in their questions in the Q&A box, and we would be happy to direct them over to our experts once the presentation gets over. Over to you, Mr. Musa and Mr. Malpius.
Thank you very much, Mayank. So I'm gonna present my screen then. So can you please confirm that you can see my screen?
Yes, it's good to go.
Perfect. So thank you very much for the invitation and for the opportunity today to talk about this particular topic. So I was thinking maybe to give you first, for those of you who don't know Dassault Systems, to give you an overview of the company. So Dassault Systems is a French multinational software company which provides business and people with virtual universes to imagine sustainable innovation capable of harmonizing product life and nature. So in a nutshell, we provide software solutions for virtual twins and product development, and we are the market leader in this area. And our flagship solutions is called the 3D Expense Platform. So today we're going to talk a lot about the 3D Expense Platform, and it enables us to model, simulate, and evaluate virtual twins and virtual experiences before creating any experience in the real world. So in detail, this is a business innovation platform that provides a range of software solutions for product development, simulation, project management, data management, analytics, manufacturing, as well as social collaboration environment for teams to work together. So you can see a couple of figures regarding Dassault Systèmes. So how big we are, how much revenue we have, the partners we have, the employees, and so on. And you can see that we have solutions, so dedicated solutions for a lot of different industries. So today we're going to talk about transportation mobility and a solution called Smart, Safe, and Connected. So we're going to go into the details, what we can offer for ADAS, and basically talking a little bit about our customers. So we are working, of course, with industry leaders, but also with industry shakers. And talking about industry shakers, the newcomers, what is interesting is that a lot of customers are coming to us to implement the 3D Experience platform. So there is a strong probability, if you are in the engineering area, that your company is already using a Dassault Systems solution. So one of the key topic which is important for us at Dassault Systems is definitely software-defined vehicles. So we are very active in this area. What we can offer together with Capgemini when it comes to AD and ADAS, this is definitely embedded in this topic at Dassault Systems. And today we're going to talk, so we're going to have examples on AD and ADAS features. So not only the verification, validation, but the full process. And but talking about autonomous driving, autonomous systems, there is a lot of topic we can cover also, like sensor design and placement, perception and fusion. Of course, the aspect functional safety, cybersecurity, lighting systems, the vehicle dynamics, the E&E architecture, the driver experience or the cockpit experience, and the topic localization and V2X communication. And just before we go into the details, so we're going to present Capgemini, but just before we go into the detail, it's an overview about what we can offer. Very simple overview. The goal is to be able to have an end-to-end process. So starting with the requirements and the system architecture, then the functional logical design, of course, the detailed design of your ADAS features. And then we are in the simulation with the generation of virtual scenes and scenario and the building of the test plan, the testing. So with a lot of different test platforms we can address, and the traceability and reports for homologation, of course. So this is in a nutshell what we can offer, and we will see that in details a little bit later. But first, we're going to present Capgemini.
Thanks a lot, Ariel. So first of all, thanks so much for giving me this opportunity to present with you the joint offer. Really very happy, especially with our colleague and partners in India. It's a really very strategic country for us. So Capgemini, at a glance, so quickly, 22 billion euro of revenues. We are around 360,000 people around the world in 50 countries, working in different industries. So as you see on the top on the right, so energy and utility, service manufacturing, finance, public sectors, consumer goods and retail, telco, media and technology. And we are about 130,000 people in India. Next slide, please. So Capgemini Group is well known on IT, but we are a multi-brand company trying to help our client on the engineering and the development of their products. So you can see brands around Capgemini Engineering is dealing around R&D for embedded systems. Capgemini Invent, taking care about digital innovation, transformation, and supporting on the design of and build of the future of a new organization. And we have many other brands so working on covering the different scope of innovation, development, and the support of our clients around the world to develop their product. Next slide, please. So let me focus on Capgemini Engineering. So it's former Altran, to maybe for whom is knowing Altran. So we are more than 60,000 engineers around the world. working on 3 pillars: product and system engineering, digital and software, and industrial operation. Basically, non-structured industrialized engineering domains, as you see on the slide. So one of those domains of Assurance product system and PLM, but also software engineering, covering both the joint offer that we are building and pushing to the market together with Dassault. So quickly, so this is a non-exhaustive overview of our clients. So as I mentioned, we are working on different industries and domains: automotive, aeronautics, space, defense, and naval, and other domains. So let's say we are trying to cover all the sectors with the major players and on those sectors. In digital and software engineering, who is one of the pillars of our growth and strategy. So we are worldwide leader in digital continuity, smart factory, advanced connectivity, hybrid intelligence, and all around AI, silicon engineering, and software. So now this is a presentation of Capgemini. Let me show you how with Dassault we can help developing ADAS system with the joint proposal for ADAS and AD. First of all, just to make it clear and visible for all of you, so we are joining our forces, Dassault and Capgemini, to build the best-in-class solution for our client. And our positioning on this joint value proposal is very clear, and this with a complementarity in terms of asset and in terms of capability. So first, Dassault is proposing an open platform covering the MBSE, the design, the simulation, and the traceability. So under the umbrella of the 3DX platform for the collaborative work, also bringing system engineering expertise and tools. From Capgemini side, so now we have high auto IT and embedded expertise, so especially on ADAS. And we are bringing process, method, and tools knowledge and all the capabilities in terms of development for OEMs and Tier 1 of ADAS. So joining our forces, so we offer an optimization of the process of validation. So with an objective to be market leader and to optimize the cost of the development for our client and to cover all the digital continuity in ADAS ecosystem. So Dassault and Capgemini offer a complete service portfolio, as you see here described in this slide. So first of all, supporting our common client in digital transformation, so based on the 3DX platform. But we are pushing a set of services, as you see, so starting from the requirement engineering and validation, all the vehicle system architecture, creating the functional architecture based on CATIA Magic, the vehicle sensor and antenna design and placement, all the testing and the simulation capabilities. So with the CATIA scanner, the embedded software engineering, and you will see after on the presentation how we are bringing value with the combination of our expertise and Dassault tools on the validation of ADAS AD software. And we are also covering all the data process with the scenario production and management for the simulation, but also the performance-driven architecture with creating functional architecture with an optimized process. Very important for automotive industry. So we are covering all the certification approval. We are supporting end-to-end homologation phase with generating all the report and documentation needed to homologate the vehicle equipped by ADAS and AD system. And to complete the set of portfolio, so we are supporting the performance validation strategies with all the KPIs and the results needed for the process of development. So without forgetting two important bricks on this portfolio, the first is the full traceability, and this is really a very important support on the process of development. We will show you a demonstration on this topic during the presentation. And the second one is the configuration management, as we are dealing with a diversity of vehicle platform, hardware, software, making a really very complex the management of the different configuration for an OEM.
Perfect. Thank you very much, Osama, for the summary of our joint proposal. So what we decided to do today is not just to show you slides, but also demonstrations. So we think there is a lot of value to show what we can do in the software directly. The goal is also to be interactive. So what we have is a full end-to-end process. So the goal, so we're going to talk today about the requirements for sure, about the system architecture and about the validation. So we have a clear path for that. Maybe a couple of words, it has already been mentioned by you, but a couple of words regarding the solutions we're gonna use. So of course, some assets coming from Capgemini and the 3D Experience platform as a kind of central platform, repository for all the information we have, a collaborative platform, and we can also use the platform for stakeholders management, project management, so everything, resource management, everything. So in this case, so what we have is a workflow in 7 steps. We're going to show to you with demo. First one, we are starting with a car maker, US-based. They choose to equip a new vehicle with a new SEC system. So we're going to have a look at that. Second step, that the system engineering, which is supervised in France by Capgemini and a Capgemini ADAS expert, and developed with system engineer in Morocco. Third one, this is then the specification. Specifications are received by the supplier in order to develop the components and design the model using software engineering in India. 4, thanks to the platform and the end-to-end traceability we have, every design document are linked and allowed to perform direct impact analysis. This is very important. This along the whole development cycle from the customer requirements to the system model. 5, with a rapid software prototyping, we are able to launch early software validation to assess the system specification with specific scenarios. And this we will see with an NCAP scenario. So this is really important. You will see from the very beginning, we are taking into account the NCAP ratings requirements. 6, when the system is enough mature, we will then realize massive simulation with environment recorded from real world situation. So we're going to show it to you. And in order to explore and focus on corner cases, that's always the goal. And 7, the last one, when the simulation are finalized, so when we have a final report, we want to generate it with all the requirements, the traceability, and all the information regarding the no-go decision. So, and the solution we're going to use, platform, but of course, CATIA Magic, Stimulus, CATIA Scanner, so and everything is connecting to the platform. So let's have a look at the first step, the first demo. So this is about vehicle configuration. So there is a need to introduce a new vehicle model with a low-cost adaptive cruise control. So here is the video. So what you can see, basically, I'm gonna just pause for a few seconds. So we're gonna use every time, so this is in the 3D Experience platform. And we're gonna use every time the same kind of dashboard with all the information we need for the project. So everything should be available at the same place for every disciplines. So we already have in the system different car configuration. So one with absolutely no ADAS features, one with a low-cost SEC, and one with a high-cost SEC. So the difference between low-cost SEC and high-cost SEC, those are the sensors in this case. We are only focusing on the sensors in this case and the ACC, but of course we can add a lot more variations regarding the car, the wheels, the color, the chassis, and so on. So here you can see what we have in the low-cost ACC, low-cost camera, rear and front radar, and this is called low-cost ACC here because there is a low-cost camera. We go into the requirements. So we already have all the requirements captured in the platform. This has been done before. And here what you can see are already the requirement for the NCAP. So with different cases, with a stationary target, with a moving target, with a braking, with the target is going to brake. So we already have all the things regarding the vehicle under test and the global vehicle target. All the information are already taken into account, but we have much more requirements at the end. So this is what we're going to see. You see, we have operational requirements, stakeholders requirements, safety goals, safety requirements regarding ECUs and regarding ADAS. So the requirements regarding the ADAS. And what we're going to use is, so what we're going to do is really to link between the requirements we already have and our vehicle configuration. So there is a need to create a new vehicle configuration and to link this directly to the requirements which are already available. And then along the whole process of defining the functional logical design, defining the software detail design, defining the sensors and the validation, everything what is related to the validation, then we will keep the requirements. So here we can see we have an example. So just for the visualization, so we have an example, no ADAS. In this case, this is not correct, no ADAS, this is no ACC. And when you have a look at the requirements in this case, you can see we have requirements regarding the stakeholder requirements regarding the ECUs, and we still have ADAS requirements. This is because we have other ADAS features in the car, not only ACC. So this is the first step. This is how to manage the requirements. So the requirement has been created before. This is possible, of course, to create all those requirements with the right semantics with the Dassault Systems solutions, and also to do a lot of different analysis like requirement in the loop with the tool we can offer to find if something is missing or if we are any conflicts between the requirements. So this is the value proposal. At the end, this is really about the variant management in the system for the OEMs, for the suppliers, really to be able to manage the different variations of a car configuration you have. That's the first step. Second step, we're going to discuss a little bit about how to manage the requirements, how to manage, how to have model-based system engineering approach with SysML, and the goal is to define an operational design model. So in our example, it's done at Capgemini France and Capgemini Morocco. So there is again a video. Hopla. So what you can see here, the full V model with the different steps we have and with the different requirements. So we have, of course, further system specification, system design, software development and integration. On the right side, you have everything what is related to the validation and the homologation. Now we are clicking on the stakeholder requirements and we have an access to all the requirements defined before. And this is basically NCAP protocol. So what is coming from NCAP. So you can review it. You have all the information. At the same place, you have all the requirements, operational requirements defined by the car manufacturer. The ADAS requirements are listed. The ECUs requirements, they are all linked together with the traceability matrix. And we can see they are also linked to other things like the safety goals, which have been defined, safety requirements, and the specific requirements. So with the validation plan, which is already available for the active course control, and we even already have a report. Normally at this stage, you don't have any reports regarding the test and validation you did, but in this case, we already had this, and it's something you can review if you have it. You have all information at the same place. And now we are using CATIA Magic, and we are connecting CATIA Magic directly to the platform to get all the requirements in this environment, SysML environment, model-based system engineering, with the different pillars. So we have a system architecture for the full system. So for the full car, we can have all kind of information regarding the car. So in this case, it's a little bit simplified. We are concentrating on the ADAS topics, but everything is present. So regarding the behavior, regarding the structure, the expectation, what needs to be done, what needs to be validated, and so on. We have also, it's coming afterwards, we also have all the information regarding the ADAS. So what needs to be done, So same topic, problems to address, behavior to put in place, what's need to be done, stakeholder management, everything is already present there. And we also have the same for the ECUs. So it's a little bit simplified. We could have much more boxes, but just to give you the overview or the impression, we have everything which is linked together with traceability between the system architecture, with functional logical design, it has been developed, and with all the requirements. And the value proposal, so it's of course end-to-end traceability. So you have full traceability, full link between your requirements and your system architecture. And you have the possibility, of course, to model everything, SysML, model-based system engineering, and then before you go directly into the software design, and you can directly connect, of course, CATIA Magic with the tool you're going to use to define to create the software code, embedded code. So this is the next step. In this case, for the sake of time, we decided not to show any video. It's not particularly spectacular. So this is, we have a demo with Simulink in this case. So we have been created the code in Simulink, and everything is directly linked to the requirements and to the system architecture. So this, I'm not going to show it to you, but if you want, of course, this is something I can show at every moment. And then I will say maybe for the next demos, I will ask you, Sama, maybe to take over, if you don't mind.
Sure. Yeah, so maybe before presenting the demo, so please don't hesitate to put your question in the chat. We'll try to answer all the questions after the presentation. Coming now to the impact analysis, and the powerful analysis from requirement to model and validation. So as you know, and as I start to mention in the introduction of this demo, we are facing a global delivery model. So we're working to develop an ADAS system. It's not a small team working in one geo. It's a global team from different geo working together. And it's really, really very important that we ensure the end-to-end traceability between the different layers of development. And we will try to show you an example in the video that we will share just now. So maybe you are very familiar with the interface, but it's important to mention. So we are starting from vehicle layer. So after ADAS and system layer, until the ECU layer. So we are connecting all those layers all together, thanks to the 3DX platform. And when we start to modify, as you see on the example, a requirement, for example, at vehicle level, like what you see here, the example, we are trying to modify in real time on the right. So writing a new requirement. This is very important that all the stakeholders taking part of the development can be in real time aware. And this is what is proposed by the platform to ensure this traceability. You will see, so we are modifying a requirement at vehicle level. You will see the impact directly with the connectors between the different, between the vehicle system and ECU model. And you see the impact, the impacted requirement to be able to ensure that all the stakeholders will optimize their development based on that. This is really very important, and we go until the model ECU layers to be able to ensure the traceability between the high-level design and the development of the software. This solution or this service is bringing a high value for our client, because we will increase the robustness of the development, and we will ensure, as I mentioned before, collaboration between the different teams all around the world. So the value proposal here is detailed impact analysis with a visual representation. Very, very interesting also for people to understand quickly what we need to modify. And as I mentioned, the multi-domain visualization starting from the vehicle level until the SUU and the software level. Now, so let's talk about in development testing. So when we develop software, so as you know, it's an agile process, and the virtualization and simulation take a big part now on this process. We represent it with this small V cycle in the classic V1, but as you know, all so we are in agile mode and with the local loop to optimize the development during the process. Here we are talking about simulation engineers who will create a virtual environment to support the development. Maybe let's see a quick video after. So when we talk about simulation, so you know, classically we are talking about modeling the loop platform. You can click, please adjust to display all the layers. In the classic world, what we are doing is we are creating a simulation environment based on scanner with the different objects, terrain, roads, modelization. We are creating scenario, static and dynamic scenarios. The output of the scenarios are connected directly to the ADAS system development, the model, let's say, where we find different layers around decision, planification, control command of the actuators, and so on. So what you see on the down of the on the right, in the red boxes. The model or the system
I can get back here.
So the model is connected to a vehicle actuator model or dynamic vehicle dynamic model, and we are creating a loop with the model in the loop platform. This is the classic one. What we did in our joint offer, so we jump a step to bring value, and we include what you see on the top on the right in the software. The software layer, we include it in this architecture. So concretely speaking, instead of sending perfect object to the system model, we are connecting the scenario and the virtual scenario to the software of perception, and our system model will consume directly the outputs of the software. With this way, we will put the software in the loop in C, developed in C++, Python, or wherever, and we will ensure a validation of this the software bricks with this platform. It was really very interesting for our client to anticipate as soon as possible on this development cycle the evaluation, the assessment of the maturity of the software, and we thanks to this virtual scenario. And we will see on the next slide a concrete example.
Or you
So
want
first
to
of all, here,
or you want to say a couple of words regarding the scenario description. So here you can see the scenario description. So we have an ego vehicle with a speed range between 70 and 130 kilometers per hour. Target vehicle, which is not moving. It's daytime and sensor configuration. This is the front camera and front and rear radars. Sorry, Oussama.
Yeah, please. So here we are launching the development of the scenario or the virtual scenario. So here is the example of our own cap scenario, so the classic one, but just to show that with the with the virtualization and the simulation, we are for sure able to create a functional scenario, but we are targeting and covering all the standards and regulation based on, for example, our own cap scenario. As you see here, it's a simple one, but you just show the type of scenario that we can generate and simulate with the platform.
So we cannot hear you well, Oussama. Maybe you can try to speak a little bit closer to the microphone.
Okay. So it's better like this?
Yeah, it's better. Thank you.
Okay, so we can move to the next one. So
maybe just, if you don't mind, just a couple of comments regarding that. So you can see here the logo of UTAC. So we have been working a lot with UTAC which is a French homologation body. And we have a lot of NCAP. So we have all the NCAP scenes which are necessary directly into the software. So we have the different libraries for the different countries. So we have, of course, Japan NCAP, Korea NCAP, China NCAP, India NCAP, Euro NCAP, Australian NCAP. So they are all present and directly available in the software. Sorry, Usama.
Thanks a lot, Ariel. It's very important to cover all the scopes. So here on the value proposal, we are mentioning the early NCAP performance system, but it's including all the standard that you mentioned with an FME in the loop validation approach. In the next slide, so we will talk about the digital twin. So digital twin is really very important for the process of development, because we will create a realistic scene. So what you see in the demo and the validation is a scenario collected, real physical scenario collected with a point cloud and with the camera frames. So we are using a CATIA scanner combined with OpenStreetMap and data from HDMap in general to extract all the information from the road characteristics, like, for example, the number of lanes, the intersections, also the road signs and object. Those information extracted will be combined with assets and developed specially to create the digital twin of the scenario that you've seen just before. So in terms of object detection, in terms of speed of the object around the ego vehicles, and we combine all this information based on with the scanner, CATIA scanner, to be able to create a digital twin. So a digital twin, it will be a copy, a dynamic copy of the physical scenario that you've seen just before. And what we obtain is what you will see here on the screen. So we have the physical one on the right, on the top on the right, and we have the virtual scenario traducing all the configuration of the scenario, but also the dynamic with the different object with a very high fidelity. So you see here, so an example of what we are able to do with this digital twin approach. So we can, with the virtual scenario, we can vary the parameters of the scenario with adding more object, more event, and extending the coverage of the validation plan. So creating a confidential on the system, so it means also testing corner cases. So what we do is starting from the digital twin in nominal condition, and we create different contexts. As you see, sun glaring the scene, the snow context, a rainy, the night context also. And what we do so is we are putting in the loop with the software perception this extension of the nominal scenario. And what you see in the, maybe we can stop the video just to explain quickly. What we see here is the green boxes is the perception based on the software. So you see, for example, in the snow driving scene, at this moment, we are detecting the object in the front of the car with the camera. It will be the case for the night driving scene and the rainy driving scene, but it's not the case for the sun glaring the scene. Okay, so it means here that our software is not performant in this condition, and you are not able to track the car in this situation. So from that, we will loop with the software developer, with the data team also, to collect, to create new scenario, to optimize the software of perception to be able to ensure the safety in this condition. If it is the case, so fine, so we will progress on the development. If we are not able to do it, it means that we need to deactivate the ADAS feature in this condition. So let's progress on the video quickly, Ariel, just for all of you to see the limit of the performance of the software regarding the different conditions. You will see that we are developing and validating. So with this platform, the detection, the tracking, and it's really very interesting approach for our clients to use it. So from physical scenario, creating a digital twin, and targeting the corner cases with the software in the loop. One important thing is with the high fidelity, as you see. So for sure, we have the representativity for the different scenario, and we ensure the robustness with the safety goals. We are working on an optimization process between the physical testing, the data collection, and the virtual approach, all under the safety regulation, safety standard, ISO 26262, and SOTIF assessment.
Thank you, Usama. So I will take over again. So now we're gonna talk about the full integration massive simulation. So how we can generate a lot of scenes and scenarios. So in our workflow, it's done at Capgemini France in this case. So here again, there is a video. So what you can see here, we already have 7 different test cases defined in the system. Of course, it is related to NCAP. And what we have is we're going to use an asset from Capgemini to create from those test cases a lot of different scenarios. So this is what you are seeing with Process Composer. This is an app called Process Composer, and it's gonna call the command developed by Capgemini. So the asset developed by Capgemini, the script, and then it will generate automatically all the different scenes and scenarios we did. So it's really strong, it's fully automatic, and it should help you. It helps our customer really to win time, to save time, let's say. So we have everything which is already created. So we're gonna look for the test cases. So we're gonna find again, so we have 9 assets, but 7 test cases. And we're gonna open so we have a validation plan which is created. We're gonna use the VNV strategy app. So we can see the different, what we have. So exo braking, exo cutting, cutout, and so on, oncoming vehicles, so different test cases. And yeah, afterwards, they are created, all the scenes and scenarios we have, and we will be able to run the different, so directly from the platform to use scanner and to run all the different scenes and scenario with massive simulation, basically. So value proposal in this case, this fully integrated asset from Capgemini ready to automate virtual scenario creation in the 3D experience platform. Pretty strong. So here, this is the video with a massive simulation. So we're gonna start directly scanner. So there is a bidirectional link between CATIA scanner and the 3D experience platform. So we're gonna start explore. This is to launch the different scenes and scenarios for massive simulation. So this is connecting to the 3D experience platform. We are in scanner again. So we find the test plan. So everything has been created with the asset of Capgemini in this case. So this is what we can see. This is the file. And here we can see many, so different test cases and many different scenarios. So I do not know how many we have. I think we have 385. So they are all here, and we will execute them. So we launch massive simulation, and everything will be solved. And what we have here is a particular scenario. So in this case, so what we are doing, it could have been done with Simulink. We decided to do it with our own solution, which is control built. So in this case, we are testing the control law for the vehicle. So it's not spectacular. Maybe you're not going to see that there is a big distance between the 2 vehicles, but there will be a braking at the end. So this is what we're going to see a little bit later. And then we will save the simulation. So everything what has been done in scanner directly in 3D experience platform. And this will be again linked to all the requirements and the system architecture. And you will be able to retrieve all the information you need. For example, the validation plan linked to the requirement and product configuration. Here you have your test cases. And if you click on the plus, you will see all the different scenarios we have. So we're going to take one of them. So you see it's passed, we have passed and failed. In this case, this one was okay. You can retrieve all the conditions of this particular scenario. So what has been done, and you can view everything. You can do it directly in Scanner, or you can do it directly in the platform, and you will retrieve all the information. So everything what we generated in Scanner will be available in the platform in this case. And I think we will even see a couple of diagrams. So here first one. I think the next one is at the speed in this case. And you can see there, so the speed is changing. So there was a breaking in this case. So you are really able to retrieve all what you did and to analyze everything directly in the platform, and even to do a lot of trade-off studies. So it's possible. And we are still using the same dashboard as at the very beginning. So it's really the central dashboard for all the stakeholders, for all the disciplines, with all the information. Everything is linked and everyone has access to the same information. So using automated validation plan generation asset, as already mentioned several times, and launching directly the simulation from the platform and access the results and all the details directly afterwards in the platform. So, and the last step, so it's regarding end-to-end traceability. We're going to have a look at that. So, and we're going to have a look at how to generate also a report. So we will see, we'll retrieve all the information. Everything is linked. So it's again a view coming from Katia Magic in this case with the system architecture. So I need to start the video, sorry. So everything is available for our different levels, as mentioned by Usama. So we're going to take the car with low cost ACC. So we have the information regarding the product configuration here, that the architecture, vehicle architecture in this case, and every time we'll be able to retrieve all the information regarding the requirements, the use cases. So what the system is supposed to do in which conditions. So we spoke about ODD, everything is available. So everything, this is regarding the functional behavior of the system. So everything what needs to be done, it has been modeled and everything is available. And maybe I'm gonna speed up a little bit. That's one. So it's every time the same. Here we have L3 with the ECUs. So we have everything regarding the systems which are interesting for us. So we decided in this particular example to have a look at the system, so full vehicle system, sorry, the ADAS system and the ECUs, and we have all the information, including direct access to Simulink, to the diagrams in Simulink, and the full code, embedded code, which has been generated. And I think at the end, maybe we have something like, yeah, how to generate a report, I guess. So, and you can, of course, automatically generate reports that you're going to use to make decisions, to discuss with the colleagues, or to discuss, even to provide to the homologation body you're going to work with. And with if you're working with partners, so for example, if you're a supplier working with an OEM, so you can send all the information automatically. So yeah, automatic report generation as a value proposal. So from the platform, a link to the configuration, link to the other tools, as we saw. So for example, to Simulink, and requirement validation status. So everything is available in the platform, and everything, of course, related to NCAP in this case. So I think we are nearly at the end of the presentations of the demos. So it was really to give you an overview about what we can offer, what we have created with Capgemini, with the different assets and tools we are using, end-to-end approach. So of course, we didn't go into the detail of the validation. So it was software in the loop, but of course we can have a lot of different things. We can have model in the loop, we can have hardware in the loop, even driver in the loop or vehicle in the loop. So we have a lot of possibilities. We tested in this case only an ACC. Of course, we can test a lot of different ADAS features. What we didn't, so what we could have done, it was not the case. It wasn't possible to show that in this presentation. But of course, we have with Scanner a lot of possibilities. So when it comes to testing the perception and fusion, taking into account the vehicle dynamics, also testing, for example, lighting systems. So it can be important to couple ADAS features and lighting systems, everything what is related to cockpit experience, human-machine interfaces, the way the system, the car is interacting with the driver. So we have a lot of possibilities, and we can use the platform at the center of our strategy. So you want to make the summary, Usama?
So I think you did it, but I will quickly jump on the slide, the last slide. So if you can display all the bricks just to quick and to let time to the Q&A session. So please don't hesitate to add your question in the chat. So as we mentioned, so we are covering the product management, we are the configuration management, we are covering the specification, the powerful system engineering, from stakeholder needs to software design, the traceability with all the value add on the collaboration and the global development process. The real-time impact analysis is very important for the with the synthetic visual view shared with you in the demonstration. We are prototyping and creating a model design with an efficient way, optimizing the bridge between the MBSE and the functional architecture to the model. We are building and proposing an automated and optimized approach for to gain on the validation plan creation, to gain time and cost, and to gain also robustness with covering all the scenario needed to validate our system. We are proposing together best-in-class simulation software, so we are accelerating the path and the software journey with the using of the photorealistic environment and massive simulation variabilization, with what you see in terms of impact on the safety and the operational domain design mastering. And last but not least, so we are supporting on the homologation process. It's very important for our client with generating all the reports, all the results and the input needed to be compliant with the standard and the homologation process in general. So quickly, this is a synthesis. Thank you very much for your attention, for the time, and we'll try to answer some of your questions on the next few minutes. Huh?
Same for my side. So thank you very much for your attention, and I hope that you enjoyed the presentation. And then if there are any questions, so we'll be happy to try to answer them.
Thank you, gentlemen, very much for that very detailed presentation. And I'm sure the audience has a lot of takeaways from it. We are getting a lot of questions, Uriel and Osama, and I'll direct them to you without wasting any time. And I'll start with the first question, which is also related to India. So this is from Mr. Rajesh K, who wants to understand how to identify the homologation requirements for ADAS in India and other regions.
So the fact is we have through our partnership with UTAC, so we have an access to all those information. The goal is, of course, to capture the information directly in the software. So that's possible. There are some methodology for that. So this is something for sure we can explain to you. And of course, after, so if you want, for example, to prepare for the NCAP testing, and of course you want to do as much as possible virtually with the software. So this is something we have, as already mentioned, we already have all the libraries for India and for other countries or other regions directly available in the software. So that's possible. We should be able to help you with our partner, with the methodology to capture all the requirements from the very beginning. And for the testing itself, so we already have all the libraries.
Sure.
Yeah, just to complement, and this is linked to another question around ISO 26262 also. So for sure, as Ariel mentioned, so we're covering all the requirements with the partnership with the UTAC. But what is important is that following a standard process, with the ISO 26 to end the 30th. And from that, we follow this process to be able to make it robust based on the Dassault platform and the engineering capabilities brought by Capgemini. And from that, so we set up not only this the PMT, but also all the experts needed to cover the delivery with what also Ariel mentioned as input, with the requirements coming from the different standards and regulation, different regions, including India.
Right. And to add to that, India is a very different market in terms of our road conditions and our driving behavior. So how does your platform sort of help engineers to design ADAS and particularly solve the challenges that we have for ADAS development, especially for the Indian market?
Mm-hmm.
You want to take it?
Yeah, you can take it.
Yeah, so for sure, one of the complexity of the development of ADAS system is to be strict or to be compliant with the specificity or the context of different regions, so including India. So we are not driving cars in India like we drive it in US or in Australia. So what is important for us, and as we mentioned in the demonstration, is to start from the physical world, from the real world, and to develop a digital twin to be able to catch the realistic behavior of the traffic in India. And this is very important. It's what we are proposing. The approach is when we start from the data collection in Indian context, so we'll create the digital twin, and from that we will vary the scenarios regarding the different conditions, regarding also adding some hazardous event, and we will stick to the Indian context. So we are doing it for different clients. We see also that the OEM in India are really pushing, accelerating on the development of ADAS. Not only the European OEM with based or with the R&D center based in India, but we see local acceleration from Indian OEM to develop ADAS and for the local context. And what we presented as a services answering this need.
Sure. I'll go to the next question from Mr. Anu. What is the difference between Simulink software and Capgemini software?
Oh, that's going to be a question for you, Usama.
I didn't understand the difference.
The question is, what? Yeah, sorry, please go ahead, Mayank.
Yeah, so the question is, what is the difference between Simulink and the Capgemini software?
Okay. So, no, so just to make it clear, so you talk about Simulink. So we are not proposing an alternative to Simulink. Okay. So what we are proposing is an asset to start from the 3DX tools, so from CATIA Magic. So with all the function architecture and the requirement, the use cases designed in CATIA Magic to generate automatically a MATLAB Simulink model. Mm-hmm. This is what we are proposing.
That's correct. So we have at Dassault Systems, we have a possible replacement of Simulink for some projects, but we know that a lot of people are using Simulink and it's a pretty good tool. So the fact is we want to be open, and that's the reason why, as Usama just mentioned, so our demos was based, so we have been using also Simulink for that. Could have been a Dassault System tool, so we did that for a video, but our goal is to be open. So of course people are using some tools and we want to be able to connect with those tools.
Yeah.
Okay.
Maybe we have an interesting question about LiDAR and radar and technology. So I think it's interesting also to link it to what we are proposing in our portfolio of service. So first of all, with this solution, with the joint solution, we are proposing all the modelization of the sensor integration regarding all the technology of sensors. So camera, radar, LiDAR, ultrasonics, and V2X, as also Ariel mentioned. So now, regarding the race or the designing complex ADAS system like level 3 or semi-autonomous ADAS features, see that, for example, we have two major players, Mercedes and Honda is already authorized to deploy the ADAS level 3. They're all equipped by a LiDAR. This becomes an important technology. especially from Valeo with the Scala 3, who's equipped integrated on those cars. So in any case, so for LiDAR technology is right now mandatory for ADAS level 3 and more. Now we are developing new technology on radar 4D. It's really very interesting in terms of cost and performance. So the race is not still close. There's a lot of innovation coming in the next years.
Right. Well, thank you for answering that, Osama. And I would like to also add, what about vision-based? What about camera-based ADAS technologies? I mean, do we see a future for them as well?
So now the Entry, platform for different AM is based only on front camera. We have a lot of feature based on software of perception, like emergency braking, adaptive cruise control, lane keeping assistant, without radar, LiDAR, and so on. So for sure, it's to be compliant with the regulation. You know, in Europe, we are obliged to involve or to equip cars with active safety system, and we use only camera. But from my perspective and my point of view, only camera cannot cover all the operational domain design, all the conditions. So when it's rainy, when it's there is snow and so on. So we need additional sensor, and especially for safety, we need a redundancy in the architecture to be able to switch when we have a failure from a camera architecture to a LiDAR architecture and so on. So it's really very important also for safety.
Okay, thank you. I'll move to the next question from Mrs. Sivaraman. Does this application help track the end-to-end process, and does it also cover functional safety requirements under the ISO 26262?
Mm-hmm. That's the case. So it's not in the demonstration, but we have this possibility to take, of course, this is really important. So functional safety, even cybersecurity, this is something we can add to the workflow. Capgemini is very experienced with that. So we definitely have a solution for that.
And to add, we are using CATIA Magic and the suite for the safety suite on our projects right now to analyze the for the risk analysis, for example, for all the safety studies in different projects. So as we mentioned, so we are covering the process natively with the joint solution that we are proposing.
Mm-hmm.
Okay. And there's another question which is sort of related to this. Is it possible to procure the license for CATIA Magic alone and not get the SysML modules along with it?
Yeah, that's possible. Yeah.
Okay, sure.
So it's always the same. So CATIA Magic is a product. So you have different modules. Then you can really decide what you would like to get.
Okay. Next question, it is directed towards Capgemini. And does the platform does Capgemini has testing setups as well, as in labs and test benches?
Yeah. So we are proposing a complete set for verification and validation. So around we call the testing factory. We have test benches, for example, in Italy, the test lab with different hill benches, and we are supporting our client on with Dassault right now to design their new architecture of hill bench to cover multi-ADAS feature. We have our own test track also, so for test vehicle, Capgemini test track in France, and we are working with UTAC also on the test as a collaboration on the test vehicle. So the answer is yes, and it's one of the pillars of our verification and validation solution.
Mm-hmm.
Okay. Another question, and this is with regard to the development of ADAS, and how do you see the development of ADAS when you factor in the alternative propulsion technologies, electric vehicles, hybrid fuels? So what are the changes that you need to factor in when you're looking at ADAS and the future of mobility?
Yeah, you wanted to take it?
Oh, It's gonna be, so maybe can you repeat the question?
So are there any specific design changes when you talk about the development of ADAS compared to a traditional ICE powered vehicle?
I'd say, you know, talking about ADAS, it's extremely complicated. So it's really a very complicated cyber system. So I think there is, for any kind of components, software or hardware, there is a need for a structured approach. And this is what we offer with model-based system engineering. Otherwise, it's really complicated to address the complexity. There is a need for a central platform, of course, for the people to be able to collaborate. There is a need for traceability. There is those kind of needs for each kind of developments in the car industry. But even more for ADAS, because this is extremely complicated. And this is the reason why we are using virtual test drives, because you really need to take into account so many scenarios. So we know that if you don't use the virtual simulation, then you will need to drive for millions of kilometers, probably, really, to be able to cover every kind of corner cases. And it's not possible, even corner cases, it's not possible on the test track, or it's very, no, it's not really possible. So the fact there is, because it's so safety relevant and because this is so complex and so many possible, you have so many possible situations, there is definitely a need for such a structured approach with a platform and a model-based system engineering approach.
Yeah, obviously, when you increase the level of autonomy, you increase the complexity, so the need for the safety also. But in terms of specificity, you see, so we have a specific sensoring for the ADAS system, so with the lidars and cameras and so on. We have also a need for high compute platform embedded on the car, so really very important to manage the software in real time and to complete the sales. So specific software for perception using a lot of AI. It needs also specific process for this development and validation.
Right. I think very well said there, both of you gentlemen. And I think, with the complexity involved in this kind of a safety critical system, I think all the technologies available are sort of few. We need to test, leverage both simulation as well as real world testing to ensure that the systems that are being developed are foolproof, and there's no loss of human life when they go out into the field in deployment.
Yeah, so, and this is really, sorry to interrupt you, this is something we can really offer with Capgemini. So bringing the virtual and the real world, or real world and virtual world together, and also to be able to do correlation between physical testing and virtual testing.
Right. And I'll consider that as the last message here. We've completely run out of time. And I really appreciate Mr. Uriel Melpias and Mr. Osama bin Musa for your detailed presentation and for answering all the questions that we had from our audience. I think it was quite a detailed presentation, and I'm sure people had a lot of takeaways from it. And we will publish this recording of this webinar on our YouTube channel in a few days' time. So whoever could not log into it completely, you can just go back to Autocar Professional YouTube channel in a few days' time, and you'll be able to see this published there. And thank you once again for logging in, for giving us your time, and hope you enjoyed this webinar. Until next time, please take care. Thanks a lot.
Thank you very much, Mayank, and thank you very much to the Autocar Professional team.
Thank you.